Hi, everyone, and welcome to our Ignite session, Azure Defender for IoT, including CyberX. CyberX was recently acquired by Microsoft and is a company that specializes in securing IoT devices for industrial and critical infrastructure organizations. My name is Phil Naray, and I was previously VP of Industrial Cybersecurity at CyberX before joining Microsoft.
Hi, everyone, and I'm Neil Krumer, formerly VP Product in CyberX prior to joining Microsoft.
Today, we're going to be talking about operational technology, or OT security, and some of the differences between OT security and IT security. We're going to talk about Azure Defender for IoT, which now incorporates technology from CyberX. And we're going to show you an example of an OT cyber attack called TRITON and how it would be investigated in Azure Sentinel. We're then going to demonstrate and do a deep dive of Azure Defender for IoT and wrap up with some links where you can learn more. So what is OT security? Biggest difference between IT security and OT security is that OT security is focused on securing physical assets, whereas IT security is focused on digital assets. And by physical assets, I mean devices like turbines and mixing tanks and HVAC systems in smart buildings, in all these kinds of environments like manufacturing, energy utilities, chemicals, pharmaceuticals. So let's talk about some of the other differences between IT and OT security. With the focus on physical equipment and processes, there's a focus on safety and availability. Availability meaning production in the factory shouldn't go down because that's where the revenue for these organizations come from. And of course, they've always had a focus on safety. Other differences you may already be aware of: specialized protocols like Modbus and DNP3 and Siemens S7. Also the use of embedded IoT devices and legacy platforms like Windows XP that no longer get security patches from Microsoft. Traditionally, these environments have been air-gapped, that is, completely disconnected from the IT network and from the internet. But that's changing now with digital transformation and Industry 4.0. But the biggest difference is that SOCs and CISOs have little or no visibility into their OT risk because there is no telemetry and layers of controls as we have in the IT environment. And that risk translates directly into business risk. The first one is financial. When ransomware hits a plant, that causes downtime, which causes financial losses. The second one is theft of sensitive intellectual property. This example is a campaign that was discovered by Microsoft security research about a year ago, in which adversaries compromised internet-connected devices that still had their default credentials. As soon as they loaded their malware onto those devices, they performed a network scan looking for other sources of valuable information. The third risk is a safety risk. And here we're going to talk about the TRITON attack, which was an attack on safety controllers. Now, safety controllers are the devices that shut down the plant when unsafe conditions are reached, such as the temperature or the pressure in a mixing tank going above a certain threshold. You're going to recognize the kill chain that you're already familiar with in IT security, but also some differences as well. So the way they got in was by a phishing attack that was used to then steal OT credentials from a workstation on the IT network. They then used those credentials to perform remote access into the OT network. Now, what we're seeing here is something called the Purdue model. It's the way industrial control system environments are described. And everything to the left of that dotted blue line is the IT network. Everything to the right is the OT network. Once they installed their malware on this engineering workstation, which is a Windows-based device, they did a scan of the network to see what equipment was installed. They figured out what manufacturers were being used and what specific models were being used, and then wrote malware that specifically spoke to those safety controllers using its native proprietary protocol, which is called the Tri-Station Protocol. The eventual goal of this attack was to disable the safety PLC and launch a second cyber attack, which would cause major damage to the plant and possibly loss of human life. Now, there's many areas in which various incidents, various activities that the adversaries performed would have been detected by a monitoring system had it been in place. Certainly, the initial network scanning would have been detected, and as well, they downloaded their malware into that safety PLC using a normal function called a PLC program update. And that would also typically be investigated to see if it was legitimate or malicious. So let's talk a bit about Azure Defender for IoT and what capabilities it provides. It's an agentless system for unmanaged devices. Unmanaged devices are devices that weren't designed to support agents. So the first thing it does is tell you what devices you have, how they're communicating, and shows a network map of how they're connected. And this can be useful for a couple of things. Number one, you can't protect what you don't know you have. And second of all, if you're implementing zero trust, it's very helpful to know how these devices are connected so you can put them on their own network. Number two, what risks and vulnerabilities do we have in the network? What unpatched systems do we have? What unauthorized connections between subnets, open ports, unauthorized internet connections do we have? And how do we take a risk prioritized approach to mitigating those risks? Number three, how do we continuously monitor the network so we can immediately know when the network has been breached so we can mitigate that attack before it causes our plant to go down or a safety incident? The next one is more around operational efficiency than cyber related. But the idea is when you have malfunctioning or misconfigured equipment in the plant, it's very hard to figure out what went wrong. By providing visibility into what's going on in the network, we can help control engineers quickly identify those types of issues. And then finally, how do we unify IT and OT security monitoring across both IT and OT? Silos that have traditionally existed between IT and OT teams, we want to break them down. And we also want to leverage all of the workflows and tools and training that we've spent years putting into our SOC so it can then be applied to OT security as well as IT security. And then finally, how do we demonstrate to auditors that we're taking a holistic approach to securing our environments across both IT and OT and ensuring that we have a safety and security first environment? How does this system get deployed? So if you look at the bottom here, we're talking about the OT network with a network switch and a span port. By capturing a copy of the network traffic through that span port using a technique called passive monitoring or network traffic analysis, we bring it into the sensor, which is an on-premises virtual or physical appliance, and then use deep packet inspection with specialized OT-aware behavioral analytics to identify assets, vulnerabilities, and threats, which are then displayed on either an on-premises console or a cloud-connected console in Azure using Azure Defender for IoT. And the alerts can then be passed on to a SIM, such as today we're going to show you how they would appear in Azure Sentinel in investigating the TRITON attack. Where does Azure Defender for IoT fit in the overall portfolio? Well, it's part of the Azure Defender family that's being announced at Ignite. Azure Defender is part of Azure Security Center for showing the risk posture of your environment. And as I said, it also integrates very closely with Azure Sentinel. And now I'd like to hand it off to Nir, who's going to give us a demo of Azure Sentinel and how it would be used to investigate the TRITON attack, which crossed over from IT into OT.
Thanks, Phil. Let's jump to the demo and I'll show you how it works. Opening Sentinel incident page, we see that we have 3 incidents coming from Azure Defender for IoT with different severity levels. Let's take an authorized PLC programming incident that is a high severity incident that has a big impact on the OT network. We want to investigate that to see if we can correlate that with other incidents. We can see that alert is connected to the safety PLC and engineer workstation. We can click on both of those entities to get their information. For example, we can see that the exact details of the safety PLC, such as its model, serial number, protocols it's communicating, and much more. We can also trace back that incident from the engineering workstation to see that it was actually performing some sort of address scan just before that incident, which means that it probably was searching for PLCs to program. And just before that, we had an unauthorized remote access connection coming in from Joe's PC, an IT computer, to the engineering workstation. We've just traced back TRITON attack flow and correlated an attack that came in from the IT network to the OT network. And we had the exact information of what happened, when it happened, the affected devices, including the details and more. Sentinel investigation really helped us understand the attack, but we want to take this one step further. With Azure Defender for IoT launch, we're also releasing playbooks to help automate investigation and response processes while bringing OT knowledge to the SOC and overcoming the knowledge gaps that is unique to those networks. Here, we have a ready-made playbook on how to automatically investigate and remediate PLC programming alerts. Let's take a deeper dive into how this playbook is built. The first thing we do is we get all the PLC programming alerts and we check where they were sent from an engineering workstation. If that is true, then we can close the incident with the reason that this was a legitimate programming event. However, if this was not from an engineering workstation, if it was an unauthorized PC that did the programming, we can check, did it happen during work hours? If it didn't happen during work hours, then this is something wrong. We can get all the logs on the attacker machine, enrich it with the incident details, notify by email to the stakeholders, and raise the incident severity level to high. However, in case this was from during work hours, then maybe because it's now COVID times, the person who did the programming was actually remote accessing to that machine from a remote location, say an IT computer. We can check to correlate, was the attacker system or was the sending system was actually being remote accessed from another computer. If that is really the case, then we go one step deeper and say, maybe that was an authorized PC that did that. Sometimes organization will assign a few computers from the IT department that are legitimate for doing remote access to program and to work on the OT network, on the operational network. If that is really the case, then we can close the incident. However, if this is not, we're currently dealing with a situation where we have an unauthorized PC doing a remote access to the operational network and doing an unauthorized programming to a device, to a PLC. So we try to correlate. Maybe this was part of a malware, part of a threat. So let's get all the indicators, all the alerts that were happening from other systems like MDATP. And in case we found another indicator of malware on that system because MDATP had another alert on that specific device, then this is a validation that this is right now part of an attack. So what we do is we need to remediate that specific attack, or we want to close that specific attack and isolate the machine. So we can contact MDATP to isolate that specific machine, raise the incident severity to critical, and send a Teams message to the SOC that there is right now a critical IT/OT threat happening in their network. In this way, we've automated the analysis for PLC programming alerts, giving the SOC time to focus only on the top validated threats to the operational network without needing to be an OT security expert.
Thanks, Nir, for that demo. And now let's summarize how Azure Sentinel can help you strengthen OT security in your organization. First, it provides a unified view across both IT and OT networks, so you can quickly spot attacks that cross those boundaries. As we saw in the TRITON example, the attack started on the IT network and moved into OT, but we've also seen them go the other way around. Second, as the industry's first cloud-native SIEM and SOAR system, Sentinel provides all of the benefits we've come to associate with cloud-based services, such as simplicity and scalability and reduced total cost of ownership, as well as continuous updates, including continuous threat intelligence updates. And then finally, Sentinel is now being enhanced with specific capabilities around OT security, such as the native integration with Azure Defender for IoT that we saw today, OT-specific SOAR playbooks that we also saw today, and then OT-specific threat intelligence delivered by Section 52, which is Microsoft's in-house security team focused on OT-specific malware, campaigns, and adversaries.
Now, let's dive into the Azure Defender for IoT interface and get a taste of the value it brings. Opening the Azure Defender for IoT on-premise management console will give us visibility for all of the sites in our organization. We can view those sites in specific contexts, like incident response, which is based on the number of alerts in an organization. Operational alerts, to look for sites which are facing production problems. Or risk management, to look for sites with the highest security risk associated with them. As you can see, Rome Chemical plant is in the red. So we want to drill down into that specific site to see what's happening there. As soon as Azure Defender for IoT connects to the network, it automatically detects all devices and visualizes them on an interactive map. This makes it easier for getting all the full context of the network and understand relations and data flows between devices, all without any configuration. The layout which I chose for this map is the Purdue model, which is a common architecture for OT networks, where controllers, IEDs, are at the bottom level, or called process control network or process control zone. The HMIs and engineering workstations are at the middle level, which is called supervisory. And at the top, we have more IT-related devices like workstations, servers, printers, IP cameras, and more. The system also automatically creates for us a group of devices, whether based on OT protocol, network, or known application. Let's zoom into the Ethernet IP OT protocol, which is a common protocol for Rockwell automation. Here, we can see all the devices that are part of this process with their connection flows and all of the information on them. Let's click on the quick properties, select the HMI. We can see the information of the HMI here in our quick properties. We can also click on the device on the PLC, which is interest for us, and we can get the connection details of those devices. For example, we can see when did they last communicated, how much traffic was communicated, and what was the protocols of which they were talking to. Diving into a specific device, I can get information on all of its attributes, such as vendor, type, protocol, and even the backplane information of that PLC with its own unique version, model, and serial number for each one of the racks and slots that he has. All this information is gathered entirely automatic without any configuration to the network and analyzed by a proprietary deep packet inspection engine that is passively analyzing network traffic. Here, we see the alert page, which contains specific IoT and OT threats that were discovered while monitoring the network. The alerts are generated from 5 major engines: protocol violation engine for detecting deviations from protocol specification, anomaly engine for detecting anomalous network behavior such as scanning for PLCs, anomaly engine for detecting malware behavior via matching IOCs or indicator of compromise. This engine is also flavored by a dedicated and specialized IoT and OT research group called Section 52. Operational engine for detecting incidents that affect the operational nature of the network, such as a PLC restart, programming, or stop. And a policy violation engine, which alerts on deviations from baseline. Since IoT and OT networks are deterministic by nature, this engine learns the network, the behavior of devices, and their use of specific functions, and alert on any unauthorized change of those. Each alert provides rich context of what happened, including the time, details of the alert, the affected devices, an ability to download a PCAP, which provides context just before the attack and after the attack, and a recommendation on what to do to mitigate that specific threat. The solution also monitors for risks and vulnerabilities in the network. And with one click, we can get a full report of all the security problems that we saw in the network. The report provides a point-in-time assessment that gives an overview security score to understand the posture of the network and how many devices are highly vulnerable, and highlights a number of key problems that were detected. The report is highly comprehensive, providing information on top vulnerable devices, network security risks, and operational incidents, and a recommendation on what to do in order to raise the security posture of the IoT and OT network. In addition, each device has its own risk score that is comprised of number of high severity CVEs, number of open ports, remote access connection used, unencrypted protocols, and weak passwords. But vulnerabilities are not the same in OT. You can't just fix every one of them and apply the same IT patch management concepts. Some devices here might be operational, and patching them might be impossible for the upcoming months. In addition, not all devices are born equal, and some of them are more important than others. Our goal in the OT network is to protect the crown jewels, the devices that compromising them will cause severe impact to the organization. This is why we've created the IoT and OT Attack Vector Simulator, which simulates possible attack paths from an external attacker to the most important devices. The engine simulates how will an attacker use existing vulnerabilities in the network, taking under consideration the level of risk and complexity of them in order to compromise a specific important device. The output is the most likely attack path that the attacker will take, thus giving the security officers information on how to better defend and plan their remediation process according to the biggest bang for the buck fixes. Here, we see how will an attacker go from John's PC via internet connection utilizing existing vulnerabilities in the network to reach PLC West 1. We can also visualize that on the map to get more context and understanding of how that attack will take place. We see that the attack goes through the FTP server. Let's try to simulate the fix for that FTP and include it from the attack. Indeed, now we see that we've improved our score and reduced the attack surface for that device. Back to you, Phil.
Thank you, Nir, for that demonstration of Azure Defender for IoT. So let's talk about how the solution can be used to provide security for both managed and unmanaged IoT devices. Microsoft offers a number of capabilities for managed devices. These are also known as greenfield devices. They're used in new projects and new initiatives. There's agentless capabilities, which leverages telemetry obtained from IoT Hub. There's also an agent-based approach, which offers lightweight agents that can be installed on all common IoT operating systems. Microsoft also offers a hardware-based solution called Sphere, which is used from securing devices from the chip to the cloud. With these new capabilities that we're talking about today, we're now announcing support for unmanaged devices or brownfield devices. These are all the devices that are already existent in OT networks around the world. And what we're announcing is this agentless capability for securing these unmanaged devices, including identifying assets, vulnerabilities, and threats through network layer monitoring. So as a next step, look for the public preview of Azure Defender for IoT in October. You'll be able to download the sensor from Azure and try it for free during public preview. Here's what one of our clients are saying. Jacobs is a global engineering company with 55,000 employees. They're using the system to provide a managed security service for water and wastewater facilities. You can see that the quote highlights ease of deployment, which is primarily due to the agentless architecture of the system, but also its use of machine learning and behavioral analytics to eliminate the need to configure any rules or signatures. I'd like to direct you to these links where you can learn more about the architecture and view some of our content, both SANS webinars, white papers, and solution briefs, so you can learn a little bit more about OT security and how we can help secure your OT environment. So that's all we have, and I want to thank Nir for doing such a great job with the demos.
Thanks, Phil, and thanks for having me.
Thanks for watching, everyone.